Thank you, everybody. First time at Vox Days Brussels and so many people in the audience. Welcome to a talk about Java 22 and what has happened with Java 22, what brought new and exciting. I'm Mihalceanu. I'm working as a Java developer advocate at Oracle, and I'm passionate about, of course, working with Java, occasionally working with Kubernetes, and hence I would like to introduce what changed in Java 22, maybe show a few things and demos, and of course there's going to be some code that is going to be shared at the end of the session so that you can try the features on your own as well. Now, speaking of Java, probably many of you are familiar with the 6-month release cadence, but I would like to get to know you better and to know which Java version are you using now in production. So I'm going to start with Java 21. So who is using Java 21 in production? Okay, we have one person here. Nobody else? Okay, good. Who is using Java 17 in production? Okay, half of the people. Great, great choice. Java 11? Okay, and Java 8? Okay, you came to a great talk. So congratulations to everybody for. Now, as you know, Java is evolving nowadays every 6 months. There's a new release. There are some features that are being delivered in the form of JEPs, of course, performance enhancements, security enhancements, and a lot coming together every 6 months in the JDK. And the way this is going on right now, it makes it more digestible for us, for developers, to get acquainted with language features or with performance changes every 6 months and to understand them and work with them instead of having everything delivered as a bulk, like you see with Java 8 and Java 9, like 56 JEPs, 91 JEPs with Java 9. A lot of change to digest, and then we wait for many more years for something to change with the language or with the platform, and then we get even more to learn. But nowadays, we can just learn incrementally what has changed and experience that and get some experiments on with that within our code. But that release model is not just for having a shorter term on giving Java to you, but is also to make features that address your pain points. So probably you've seen with each release that they say, hey, this JDK enhancement proposal belongs to JEP XYZ. This JDK enhancement proposal belongs to another one. So you see these projects probably set there. And these projects are there to address some of your pains with, let's say, with the language. You would like to do things, you would like to program with Java in an easier way. Or maybe you would like to have concurrency in a lighter way and not depend anymore only on the platform threads, have more throughput when using threads, for example. Maybe you would like to integrate with native libraries easier, much more Java-friendly than using GNI. Or you are looking into improving the throughput of your application by looking at the garbage collectors that exist, and maybe some garbage collectors have that performance improved with each release. Now, as you can see in the slide here, there are a lot of the pain points and a lot of, let's say, inspiration from the competition that Java has had throughout the time. So I know that a lot of people say, hey, but Kotlin had that too before Java. Sure, but we are all in a community and we learn from each other. And it's great when other languages are also, showing features and we're learning from those to make Java even better. But Java has a great advantage. It's always backwards compatible, and every feature, even if sometimes we wait a little longer for that feature to come up, is thought to make an easier way to you to migrate to that feature and not to be like very abrupt and say, hey, sorry, your code base that you had before is not going to work with this. You have to rewrite everything. Would be pretty bad. But most of the features that we looked at, those projects, those big projects from there, those are big improvements. Yet most of us start small, right? So whenever we are writing a piece of code, we're not just writing a lot of methods, a lot of classes from the beginning. We don't have the entire model in our head when we are going to do a task, right? So, and historically, Java has been thought for big systems, like think of the ERs or the big Java EE enterprise applications. Those were big, right? However, how about having Java for small things, like for microservices or for CLI applications? But that requires a little bit less ceremony, especially on the language side. So that's why the term of paving the on-ramp was introduced with a series of changes to make Java much more approachable, especially for students, so that they can learn it in a much more friendlier way and have a simplified beginning. And I'll talk about the simplified beginning a little more. So specifically, Project Embark is focusing on introducing some language features in small chunks. You sometimes get once, twice, 3 times previews of those until they become final. With each preview, there's feedback. The feedback is incorporated and, of course, is taken action upon it. Now, towards a simplified beginning, if we are to write a hello world, nowadays we have a few options to do that. Okay, you can write a Java file, but you can also use JShell as a tool to fast prototype that code. Furthermore, if you want to launch it, you don't need to compile it and then launch it. You can just use the Java launcher and say Java hello world Java. No more Java C, and then the Java on the class file that resulted there. But let's look again at this. This shows a lot of ceremony. I mean, if I just want to print hello world here, I have to first write a class, I have to write a method, I have to use string args, and then I have to system out the print hello world. And funny thing, I'm still not using the arguments here. I'm just wanting to print a small string. What the JEP 463 has introduced in Java 22 as well with the second preview is making this hello world, this beginning less ceremonious if we don't need this many elements in it. So what this means? This means that if you don't necessarily need, if you want to just print hello world, probably you don't need the accessor that is public, or many times maybe you don't need even the class and you just need the method, like a little procedural way to write Java, right? But let's think of that as like scripting it. Then maybe you don't need also to have that method public. You just want to run that specific one file with some code there. And then, if we are to look at this, why make it static? So, and secondly, since we're not using the arguments, why have them there? So remove all the extra ceremony just to have the hello world there. So in the end, if we are to look at how we would effectively script hello world, it would be just a simple void main and a system out print line there. Now, a lot of folks have asked, hey, but wouldn't it be better if it would be like void main and print line hello world? So this is a feedback that is taken into consideration just to have it even more simplified so that you don't write also the ceremony with the system out there. So stay tuned. There probably is going to be some change over there soon. But just to summarize it, the class declaration is not always necessary. If you're not using packages, if you're not structuring your program in a complex way, you just want to write some code to see if it works, you just can write void main and no class declaration needed. Then main is not necessarily having the ceremony of public, static, and so on. And if you're not using the arguments, why give them as parameter there? So this JEP had a second preview. Give it a try. It's pretty cool for writing programs that are executable from CLI. So it's going to simplify life, especially when it comes to scripting with Java. But how about the invocation order of main? So what now if I have multiple mains? I have the public static void main, and I have all these other types of mains that are there. So if you're right now trying to write different mains, they are going to be considered in a different, in a specific order by your invocation. So, of course, if you're having a public static void main string args like you used to have, that one is going to be considered first in execution. However, the second one that's going to be executed, let's say you're going to say also static void main method in the same class, that's going to be the second one executed. The third one, if you have like a void main of string args, and the last one is the simplified version of void main with no argument. So that's how they would be evoked when using this feature. There's no problem in compiler issue if you're having all four like that. Another thing that came with improving the way that we are working with Java is the way that we are working with programs supplied as multiple files. So probably you've written programs, actually, you've written Java as multiple classes. There is inclusion, there's sometimes inheritance, and so on. They belong maybe sometimes to different packages, right? And if we are to use the launcher, even the Java, Hello World Java launcher, in this case, they will say, hey, you also need to compile also this dependent helper file as well. So what JEP 458 introduced, and this one is a final feature, is the ability to launch a multi-file source code program just using the Hello World Java there. So just to give you an idea on how that would work, actually this one doesn't need the preview. I made a little mistake in the slide. Let me show you something interesting. So I have a small project. We're going to take these requirements a little later. So I have a project that uses some preview features as well of Java 22. And in the past, I would have used Maven, for example, to verify my project, to generate a jar, and maybe to run my my project there. However, the entry point of my project is the wrap-up class. It has a void main. So why can I not execute that class and then go in a domino effect and execute my program successfully? Before Java 22, well, I had to compile and launch every file and then to be able to run the wrap-app.java. But thanks to this feature of having one command to launch them all I need to give here is a dependency to like whatever external library I'm using. And in this case, I'm using the JSON library. That's why you see here the export path to JSON. So what I need to do in this case, just set where this path to JSON is and give it on the class path and then launch my file. So let me make this a little bigger. Java. As I said, the -- enable preview is just needed because I have preview features in my overall project. Then I need to give the class path to my external library, so no more Maven needed to put everything in POM just for a simple program. And say JSON 2023 1013 jar. And then I need to give the source of my wrap-up file. So let me just go here, copy path reference, and this one. So now I have created the reference to my wrap-up file, and I just can launch it. So what you can see here that I started my application is running. I didn't need to compile anything extra. Let me see. No, there's no target file. There's nothing else needed. I just was able to launch my application with no more ceremony involved. So that speeds up things a little bit for us when it comes to running Java applications. Now, if you want to know more about these features, there are a few videos where you can learn more. Like specifically, there are some newscasts that my colleague Nikolai has created on these features, but also more about the JEPs are here in the slides, so all the links are provided. At the end of the presentation, there's going to be a link to the slides as well. But not just beginning with Java and launching Java files has become easier with Java 22. There has been a thoughtful evolution of the Java language features as well. Oh, sorry. And these Java language features have been evolved according to the JDK expectations to have compatibility, stability, and also security with the previous versions. So you saw earlier an application. Let me tell you more about it. So what you saw earlier is a wrap-up application. What that application is a simple server that is receiving requests from a sender to send a gift. So people can send a gift by using a simple JSON request to that application. Now, a gift can only be a postcard and something else. So it can be a postcard and a present, which could be a material present, or a postcard and a coupon, or a postcard and an experience, like, I don't know, jumping with parachute from a plane. So those can be bought through the application if you're sending a request to the wrapapp.java. Now, the postcard doesn't have a cost. That comes for free. The other three have a price. And of course, the sender can never send two postcards. I mean, why send two postcards? You can just send one postcard and that's it. An online coupon obviously has an expiration date. When you buy a coupon, it's not forever available. Of course, a present, when you buy it, you can place it inside a box. And a coupon can be bought for sharing an experience too. One possible way to model that would be using sealed types. So let's say that you're having a sealed interface intention, and you know that, well, I can offer a couple of things. I can offer a postcard, a coupon, an experience, and a present. So I can use this data type to limit which kind of resources can directly implement or extend my model. At the moment, my requirements are only the ones that I presented earlier in the slide. So just having this sealed interface would satisfy my needs. But moreover, there was something said there that a coupon can also be bought. I mean, experience can also be bought as a coupon. So I can have the class experience that implements intention and permits coupon as well. So coupon can extend from experience as well. If I'm to look a little bit more in detail, I can just model present and postcard as records and have immutable data types to work with. And then I can just have coupon as a class that is extending experience and the behavior of experience to give more details, well, like a date of expiration. And lastly, I can represent gift using composite patterns. So, closer look to this one. I can model, firstly, the coupon using inheritance and constructor chaining. So this is not something new. But let's say that the price has to always be positive, right? And in the case of experience, experience always expects for the price of an experience to be positive. When I am sending some data to the constructor of experience, with what I had so far until Java 22, I could have done a super for about verify positive for price, have that private static method over there, verifying the price, and call that and pass that through the constructor to make sure that I'm sending a positive price to my parent class. Why couldn't I do it differently? Well, because historically speaking, no statements are allowed before super or this, because ideally the superclass in that case should be initialized before the subclass runs any other code. So that was not possible before 22. So no code before this. Yet, ideally, a constructor, like in this case, should check the arguments and assign them before going to the parent class. So what is available with Java 22? So here's the constructor chaining, and with Java 22, we can write this kind of code and have statements before super. So we can have the check of the price before invoking the actual super with the value there. So in the case that the price is not 0 or greater than 0, there's no point of invoking the super for price and throw an exception. So that was one change, but it's great in this case that we can validate the superclass constructor arguments before actually going to the superclass and avoid using that private static void method, which is kind of painful to also test. Secondly, we can prepare the superclass constructor arguments in this case. And lastly, this kind of approach could also be used to share superclass constructor arguments. Yet, thinking back to my first model, if I'm modeling things like this with coupon extending experience and, well, even if I'm using sealed classes and final to make sure that the coupon is not extended anymore, I have one issue. I always have getters and setters so I can modify the data. And I want to make sure when I'm sending a request to the system, I'm sending a request, which is immutable data. It's been sent by me. I know what I want as a gift. And I want for the system not to manipulate that data too much, and I want to make sure that the request is there. So I want to have immutable data coming from the system as well. Another way to model this more expressively would be to use records also for experience and coupon. So my system would change in modeling in having records all the time and have that immutable sharing, have that immutable data for all my models. This is much more expressive to share and to have detailed for my system. So we're keeping the sealed interface. We're not extending anymore because we have records. We keep coupon, experience, present, and postcard as records. And of course, we can represent gift using nested record patterns. Now, why am I doing this? Because I have some other conditions for my system. So I want to make sure that whenever somebody asks for a gift, even that they have mistakenly said, give this for minus 10 euros, I want to say, hey, I cannot process that, and I can give you only a postcard, for example. Or if somebody has said, I would want to send 2 postcards, once again, send only a postcard. And in the case that they selected correctly when sending a gift, I can properly merge the postcard and that specific type of intention together. So from maintainability point of view, I can have a reply from my system for the gift without using the if-else-if chain for all these cases and run everything and show everything as a switch. So in this case, I'm using pattern matching for a switch over my records, and I'm keeping it exhaustive. So what this means is that I'm switching over all the sealed classes. I have a case per each subtype of my gift and situation for the gift. So in the case that there are 2 postcards, I'm just sending the first postcard. In the case that the price is 0, okay, once again, the postcard. The part when the price is negative is being treated in the constructor of the record, by the way. And in the case that postcard and experience are great, then they are merged together and being sent to the requester. But this kind of experience also helps me to avoid using the default branch, where we used to chunk together all those cases that we are not treating. And why is this very important? Because, well, I've used sealed classes. I want to make sure that I'm modeling only what is requested to me at that moment. If there's going to be another request to have another type of intention, I will probably model that as another record. I'm going to permit it in my intention. And then the compiler is going to notify me in the switch and tell me, hey, you have forgotten a case for your gift. You have to implement it. Otherwise, this switch is not exhaustive. But there's another feature of 22. And all these were happening in Java 21. But in 22, JEP 456 about unnamed patterns and variables was finalized. So this is one final feature where code for that, what we had before, is becoming more readable and more maintainable. And what I mean by that, so in the cases where I'm not processing the data from the case, like in the first case, I have postcard P and postcard P2. I'm not using the second postcard in the response, so it can be an underscore. So that gets anonymized since I'm not using further in my code. But look at the last case, right? Feels like a lot of stuff bundled together. So in this kind of case, what we don't have a default branch. But we can think of this case, the last one, as a combination of default branches, because it was the same gift that was merged, right? So thanks to this feature, we can bundle in this pattern all together those 3 and have just one response instead of having a case for each of them, since they all return a merge for the gifts regarding of that. And because we're not using any of those in the reply, they're all anonymized there. So if you want to know more, there are a few links that can help you understand more about what happened with pattern matching. And also, I would recommend for you to read something that was sent on the mailing list about uniform handling of failure in switch. So an improvement to handling exceptions in switch, and especially in exhaustive switches. Now, these were the language changes, but there were some changes that happened at the core libraries as well. So historically speaking, we're all familiar with how we are writing Java, compiling, and then we launch it. So I know that I showed you the launcher that doesn't go with the compilation part anymore with the Java-C, but ideally we were going through this. Now, the class file that the compiler generates from your Java code, they contain bytecode. So those Java bytecodes are an instruction set for the Java virtual machine that are consisting of operations like creating objects, like copying variable values or references, or invoking methods, computing arithmetic operations, and more. But when that is going to go into the Java runtime, the class loader will load, parse, and verify that bytecode before passing it to the JVM, which executes it. So let's look again at how bytecode gets manipulated. Because bytecode can be generated, viewed, and changed at every step of the way. And there are frameworks, by the way, that generate bytecode when your project gets built to avoid reflection at runtime. And today, earlier, there was a presentation on Micronauts, so that is one of the frameworks that does that. Another one is Quarkus. But also, not just frameworks are manipulating bytecode. Also, tools like JDEX, for example, can parse bytecode and analyze the dependencies. There are static analyzers that are using this bytecode to actually understand what's going on there and give you a static code analysis of that. But also, agents can manipulate the bytecode when the class load is loaded via the class loader, for example, to gather performance information. Now, these don't happen by themselves. So these tools don't orchestrate things by themselves. They use bytecode libraries, which are most of the time dedicating to parsing, generating, and manipulating the bytecode. And one of the big players of the bytecode libraries is ASM. But there are some other bytecode libraries that manipulate the bytecode, like CGlib, which is used by ByteBuddy and Spring, if I'm not mistaken. So what this means, the multitude of these libraries that manipulate bytecode? Well, the fact that they manipulate bytecode in a different way, that means they have to also keep up with the Java version that is being released. So the bytecode version is or the level of so-called level, is encoded in each class file and currently increases with each Java release. So probably if you would have run Java 21, you could have seen that the level is 65. If I'm compiling now with Java 22, level is 66, right? So while these bytecode is generated by frameworks most of the time at the runtime, they can have differences when we're trying to update to a different Java version because of the different bytecode libraries that manipulate it. So this kind of makes, for us, to upgrade to Java a little bit much more difficult, sorry. So imagine this, like if a framework is using a library that is not yet updated to use a certain, that is using a bytecode manipulation library that is not yet compatible with a certain Java version, you have to wait for that library itself to get updated. So that's why you're always thinking when you're updating to Java and you're checking for your dependencies if it is already working or compatible with a specific version. Now, what the new class file API is proposing is to have an API that manipulates bytecode provided by the JDK and can be used by frameworks. So this is an API that makes it available to have like a uniform manipulation of the bytecode embedded in the JDK. And imagine this, when there's a new Java version, if a framework or a library is using this API, the migration would be seamless, because the JDK with its API would take care of that migration to the new level. It's not going to be anymore on the shoulders of that specific dependency to do it. So this change, the class file API, is Java 457, was introduced in Java 22 as a preview, and is aiming to make our migrations a little easier once the frameworks or other libraries are going to make use of it. It's not intended necessarily for day-to-day usage in the developer life, if you already are using a framework, but mostly if you are building a library or a framework. So if you want to know more, there is a JVMLS presentation from last year by Brian Goetz. And there's a newscast that explains how the class file API will make the Java updates easier done by my colleague Nikolai Parlog. Apart from that, the core libraries also looked at some unfulfilled streams operations. So some of you said that they're using Java 8. So everybody who's starting with Java 8 and above probably are using Streams API, right? And we love the Streams API. It was great. And it was designed specifically for Lambda expressions, right? And we love that the stream is lazily computed and has a potentially unbounded sequence of values. But also this API supports the ability to process a stream either as a sequence, but also in parallel. And when we're writing a stream, we're usually writing three parts of that. A source of our elements for the stream, any number of intermediate operations like filters and so on, and of course a terminal operation, which is usually a toList, toMap. We're collecting everything together as a response. However, there were some operations that were missing. So in this case, if you're looking at paginating an array list in chunks of 3, you could, with what you had until 22, you could write this easily even with Java 8 as an instrument range and a lot of complicated operations in between. So calculate something about the size, make a minimum of the size, and a lot of complex operations in between just to have that output there, A, B, C, D, D, E, F, and G, H. What happened in Java 22 is that some of these intermediate operations got a solution that is called gatherers. These are intermediate operations like sliding windows, take while including, and others are now fulfilled by a new API called Gatherers API. Now, Gatherers API is in preview, but addresses all these needs, and I shared earlier. So, what it has, a generalization for intermediate operations with the Java Util Stream Gatherer interface. Also, so you can make your own gatherers. You can write intermediate stream operations to process elements via stream gather. And of course, there are a few implementations with the gatherers collection, like gatherers fold, gatherers window fixed, scan, and so on. So what I had earlier explained of, paginating my array list in chunks of 3, I can now write with gatherers and window fixed provided function, in, like saying window fixed of 3, and then join on the window and gather that to a list. So much more elegant, no more math usage, no more intermediate calculations and complicated things. So it's a great way to also compose these operations. So it's not just you write one single gatherer and that's it, and then you have a terminal operation. You can have multiple gatherers that you can compose them, usually with the source gather and then gather more and then collect all that. What are the components of a gatherer if we're looking to it? So these are the components of a gatherer. The mandatory part is the integrator, and that one always needs to be implemented if you're making your own gatherer, is the core method where the actual data processing logic is defined. So because you have to dictate how your gatherer will process the stream element and incorporate it in the current state. So this gatherer accepts the state element, and of course, the current state of the gatherer will process the element and probably will emit that to the downstream. Now, it also has optionally, if you want to implement it, an initializer that creates the private state of the object, so the private state object of the gatherer. The combiner can evaluate the gatherer in parallel. So gatherers can also process data sequentially or in parallel. And when parallel option is being used, that's when the combiner needs to be implemented as well. That's why it's optional, because by default, maybe you would try gatherers as sequential operations. And last but not least, the finisher is the one that is looking at the state after everything was processed and then sent to the downstream. So if you want to know more, there is a great presentation from DevOps Belgium last year done by the author of the gatherers, Victor Klang. And of course, there is the better Java streams with gatherers. There's newscast done by Nikolai, once again, on how you can learn and use gatherers and all the provided methods there. Let's talk about also Java to native interoperability. There are a lot of talks about AI at this conference. And historically speaking, when it comes to interacting with AI, people are used with having Python or other kind of libraries to interact with that instead of using Java. Now, why not use Java and other ways to interface with what is provided as native to manipulate code instead of all the others? Well, because to interact with the native libraries historically, we had to use GNI. And what GNI model has, well, it looks at the native code. You have to make some interesting code, to say so, which is not 100% Java, but sits in between your Java code and your native code in order to have that manipulation of what you had in between so that you can communicate with your native code. And it kind of puts in the projects an extra part of code which is not 100% Java for you to always maintain and up to date if the native code library is changing. And one problem that GNI had historically, besides maintainability becoming a little harder, is also the fact that it is having a few functions that are critical accessor functions. And these functions give you direct access to data structures inside the Java object heap without requiring that they are copied. And they give you a great performance boost. That's a good part. But these functions that are listed there, they are so-called critical functions, and the code that is executed there should be somehow signaled to the garbage collector never to be touched. So before Java 22, what was happening, that the garbage collection was halting, especially in G1 GC, when it was encountering this thing, but it was not just for them. It was for everything. So this introduced a lot of latency, just when you were handling these kind of functions. So the change that was introduced with JEP 423 is that only the regions that are using this specific functions should be avoided not to be cleared by the garbage collection, while the rest of the garbage collected eligible parts can be collected. And thus, there's no more waiting time and pause time introduced when running this code. But GNI has also another great property. So unsafe, the unsafe class allows you as a developer to directly access the CPU and other hardware features. And you can manually manage off-heap memory and other stuff. But as the name says, unsafe is not actually that safe. You kind of have to know what you're doing. And many memory leaks were occurring from misusing the unsafe. So in order to prevent this from happening, the foreign function and memory API, which is more Java-friendly, no GNI need of using, has been proposed, which has been finalized in JEP 454. It had many iterations as incubator and preview, but now is finally done. What this approach is having 100% Java code for you to interact with native library. So for example, let's say in this code that I want to use the string length function that is provided natively on my Mac, right? So what I can do, I can search for the function name string length and get the lookup for the string library using the linker. Then I can allocate the foreign memory very nicely, no needed for unsafe or other usages of objects. And then I can get the method handler for string length using a downcon handle here. Last but not least, I can invoke the foreign function with the handler and using the invoke on that specific memory segment. Much more elegant and safer way to get access to native memory. So this is the part with the memory API and finding a foreign function on my system. Another way to interact with native APIs is to actually convert them into Java code and then use them as Java code in your code. So in this case, what I have the string h that is on my laptop, and I've used JExtract a tool that helps me to convert native code into Java classes. And the output of that is Java that I can use in my code. And furthermore, I can have the class FFM benchmark to run what you see here. Well, let me show you another cool example quickly. So, first of all, JExtract, always take the binaries that are available on, oh, wait a moment. I have to remove this. For JExtract, always take the binary from JDK Java.NET JExtract, because they're already compiled with the right CLang library. Once you have the binary, there are a lot of samples available. And just to demonstrate for you, I'm going to take the teapot sample, because Macs have OpenGL and GLUT locally. Now, there is a little lack of support in the latest Mac releases for that, so I'll need to perform a little magic to have a teapot running with OpenGL native code, but transformed to Java by JExtract. So in order to do that, I need a file called compile_flags.txt to give the sources where my frameworks, my OpenGL and GLUT frameworks are. So that's what that -f stands for. And then I need to compile, actually, I need to run JExtract command to create Java code from the GLUT OpenGL classes. So let's go back here. Let's go to Java 22. Just make sure that I'm in the right folder, compile flags. So my compile flags has the file there. And then I need to create I have to convert my GLUT and OpenGL that are natively embedded on my laptop into Java using JExtract. I'm a little bit behind, so I'm just going to copy-paste the command and explain it. OK. So what the command is showing is like, hey, JExtract, extract to a package called OpenGL, and use the library called GL, that stands for GLUT. Use the current GLUT version that is on the system. And of course, what I want to have exported to Java, all the files that are related to glut.h, which is the header file for GLUT in this case. Just run enter. And what I got, if I'm going to refresh here, I got an OpenGL folder with a lot of weird, let's say, called files, but actually are Java files that were already, so they're OpenGL files translated to Java for me, so I don't need to manually write this. Now, let's run the teapot quickly. Copy paste this to the advent. No. So let's run the teapot. Of course, a lot of compiler errors, because I don't have the right imports. So all the methods that are here that are originating from GLUT, can very nicely import them using my package name and have it here. Good. Now, there's another problem here with the GLUT display function callback. So depending on the implementation that exists on a system, it can be callback, translated to callback, or to func. So let's just find the GLUT display function. GLUT display $func. Let me check. Import. .advent.opengl. Not GLUT display function. OK, good. So we got the GLUT display function, and I am expecting for a GLUT idle function here as well, because I have a local to this. I renamed reference. Just going to assume that it generated a function again. glad idle function. And now once I'm done with this, I just need to run my code. In order to run this natively, I need a few things. I have to enable native access for all unnamed. So let me just go modify run configuration, VM options for the all unnamed. Let me just check if this one is going to run it. Uh-oh. Yes, cannot find the lib. I think I also need to give this as well. Mine is the library Java path, so I need to give the library path as well. More running debug. Apply. Come on. libgl cannot find. Okay, I'll find this afterwards with the issue that, but maybe I can find it like this, local history. No. Yeah, I used to have this running, but I've got the right flag. So we'll continue with this one until the end of the presentation. If you want to know more on how you can use and JExtract binaries and how you can run native code, there are some samples over there, and they are provided also for Windows. And there's also another part of Panama that I didn't touch in the presentation, which is the Vector API. You can learn more about using the Vector API in the JEP Cafe that was done by my colleague, José Pomar. The last part is dedicated to Loom. And what came new with Project Loom about structured concurrency and scoped values. Now, probably many of you have heard about virtual threads. That was their big GA with Java 21. And the big advantage with them that we have threads that are managed by the JVM scheduler and can get the task from you. That is being done, then propagated to a specific platform thread. The virtual threads then they're going and going to use that specific platform thread. But if they halt, for example, or if the virtual thread has some blocking operation, they don't keep the platform thread from running further. So what they're doing, they're releasing that, and the platform thread can take another thread and continue to running. So they're much better when it comes of throughput. There's still a huge adoption going on when it comes to virtual threads and Project Loom. Most of the frameworks have embraced them once JDK 21 was released. And you can see here Helidon, Spring Boot, Quarkus, Vertex, all of them taking advantage of this new type of threads so that they can become much more productive from throughput point of view. But there were two more changes that were in preview with 21 and got more previews with 22. And that comes with structured concurrencies. So structured concurrency is a way to create a relationship between existing threads. So in this case, if, for example, I want to say that I want to offer a present fast to my end user when a present is being requested, and there are 4 offers available for getting a present, what I can do, I can launch those offers in execution, send the tasks to get offers for my present from different providers to say so. And they become 4 tasks as children as a scope. I join those subtasks with scope join, so they serve the same purpose. And when the first subtask is completed successfully, that one is returned to me in the scope result. So whichever of the offers completes first in my subtask is being returned to me. So I'm not waiting for all of them to process, because what I have done in my structured scope, I said on shut down this task on success, whenever my first task succeeded, there's no point in waiting for the other 3. I got an offer for my present. So One other good thing about using structured concurrency in these cases is that you can capture in the thread dumps the connection between the subtask executing threads, as those are visible there. This gives you a very great benefit when it comes to scaling applications. So you can have high concurrent requests, but with fewer operations and threads spending significant time just waiting, just by combining structured concurrency with virtual threads. Another feature that came over was about scope values. So let's say that I have another demand saying, find me the best price, the best experience, the best in price experience, like the one that is the cheapest. So how can I do that? I have a data flow. In my application, I can say that, hey, in the wrap-up part, when I am starting my application, I want to return an experience. But I don't want, first of all, to return an experience on demand if that is not a valid request. So let's just say that if the valid request is being fulfilled from the user side, meaning there was a price that's above 0, it's not an empty field in any of my requests, then find offers for that experience. In part of the record, how that gets translated is that once again, I'm looking at the scope, and I can get 4 of the offers there. So I can simplify the reasoning of the data in this case because my scope value from the parent class, from wrap-up, is being copied to my experience scope where my 4 children are there. And that is being all launched in parallel, and the scope is being joined as well. Now, this means that the data is shared by the caller and can be retrieved only by the callees that are there in read offer 1, 2, 3, and 4. Then in the end, when I'm returning the offer that is having the minimal price over there. And if you want to know more, there's a few places where you can find more about structured concurrency, and also I'm going to provide the code at the end. There's more available on dev.java if you want to learn. There's an article about virtual threads over there. Usually the language features and all the news that are about Java are gathered on inside.java. And if you want to learn about Java 22 in only 2 minutes instead of spending 50 minutes here, there is a great video done by my colleague Billy Coranda on youtube.com/Java. Thank you very much. This is the code. There are slides. And please scan it. Thanks once again. Sorry for the rush.